It is a world of unimaginable cold and darkness, a place long thought to be utterly barren. Yet, deep beneath the vast frozen expanse of Antarctica, something extraordinary has been found. Scientists, driven by curiosity and an unyielding desire to understand our planet, embarked on a remarkable mission. They journeyed to a remote part of the continent known as the Camb Ice Stream. Here, the ice is over 487 meters thick, a seemingly impenetrable barrier between our world and the secrets locked below. For many years, we believed that only rock and stillness lay beneath this colossal sheet of ice. We are now learning just how wrong we were. This frozen continent is far from static. It is a place of hidden movement and surprising life. The challenge was monumental. Using a powerful hot water drill, the dedicated research team spent days carefully melting their way down through the ancient compressed layers of ice. It is a slow, methodical process, requiring immense precision and patience. Each meter drilled was a journey further back in time and deeper into the unknown. Their goal was to reach the very bottom of the Ross Ice Shelf, a floating platform of ice the size of France. They were searching for what their instruments had suggested: liquid water. Finally, after piercing the final layer of ice, their borehole opened into a vast, dark cavity, a world that had not seen sunlight for thousands of years. They had successfully reached a hidden subglacial river. What they had discovered was not a mere trickle, but a colossal subterranean waterway. The cavern housing this river was immense, estimated to be as tall as a 30-story building and as wide as an entire city block. It was a river on a grand scale, flowing slowly in the perpetual darkness, more than a kilometer beneath the ice surface. This hidden river is part of a complex system where fresh water, originating from lakes further inland, slowly mixes with salty seawater. The seawater seeps in from the ocean, hundreds of kilometers away, traveling far underneath the floating ice shelf. This mixture of fresh and salty water, combined with the immense pressure from the ice above, is what keeps the river from freezing. The sheer existence of such a massive, flowing river system so deep beneath the Antarctic ice was a monumental discovery in itself. It completely changed our understanding of what happens at the base of these great ice sheets. Scientists had long theorized about the presence of subglacial water, but to confirm it with a direct view was a groundbreaking moment. This liquid world proved that the boundary between ice and rock is not a simple, frozen interface. Instead, it is a dynamic, wet environment where complex processes are constantly at play, shaping the ice from below in ways we are only just beginning to comprehend. The discovery opened a new chapter in polar exploration. As the scientific team lowered their cameras down the borehole and into the newly discovered river, they were simply hoping to study the geology of the cavity and the flow of the water. They aimed their lights into the murky depths, expecting to see only rock, sediment, and the underside of the ice. What they saw instead left them utterly astonished. The camera's beam suddenly illuminated a flurry of movement. Swarming in the darkness were hundreds of small, shrimp-like creatures. These animals, which resembled tiny lobsters or amphipods, were thriving in this extreme environment, completely cut off from the sunlit world above. It was a discovery that no one had predicted. These creatures were living over 400 kilometers away from the open ocean, in a place that receives no sunlight whatsoever. This immediately raised a profound question. What were they eating? In the surface world, nearly all life depends on sunlight, which allows plants to produce energy through photosynthesis. But in this perpetual darkness, a different kind of food web must exist. Scientists believe that the nutrients supporting this hidden ecosystem are carried in by the water. The slow-moving river likely transports organic matter and minerals from far away, providing the chemical energy needed for life to take hold and flourish in the absence of light. This finding suggests that entire communities can exist on chemical energy, much like life around deep-sea hydrothermal vents. The presence of a whole shoal of these crustaceans implies that they are not just occasional visitors who were swept in by chance. Instead, it points to a stable, well-established ecosystem that has likely existed for a very long time. For a population of animals this large to sustain itself, there must be a consistent and reliable source of food. This suggests that the subglacial river system is not just a geological feature, but a biological habitat, a hidden biome with its own unique rules for survival. The discovery forces us to reconsider the boundaries of where life can exist on Earth and opens up exciting new possibilities for what might be found in other extreme environments, both on our planet and perhaps elsewhere in the solar system. This unexpected glimpse of life has sent ripples of excitement through the scientific community. It demonstrates that even the most hostile-seeming places on our planet can harbor complex communities. The mission, which began as a geological study of ice and water, had suddenly become a biological expedition into an undiscovered world. The researchers now have a new set of questions to answer. They want to understand the entire life cycle of these creatures, identify what they feed on, and determine how they have adapted to survive under such immense pressure and in total darkness. This remarkable find is a powerful reminder that our planet is still full of mysteries waiting to be uncovered. Further investigation has revealed that this subglacial river is part of a much larger and more dynamic plumbing system. It acts as a major drainage channel for a network of lakes hidden even deeper beneath the Antarctic ice sheet. These subglacial lakes are not static pools. They fill up with meltwater over many years, like vast slow-motion reservoirs. Then, approximately once every decade, they drain in powerful sudden surges. When a lake drains, it releases a tremendous pulse of water that flows into the river system, dramatically increasing its volume and speed. This decadal flood is a powerful event that reshapes the world beneath the ice. These periodic floods have a profound effect on the ice shelf above. As the surge of water rushes through the river channel, its force is strong enough to carve new pathways into the base of the ice. It erodes the underside of the ice shelf, changing its shape and texture from below. This process is crucial because the base of the ice shelf is not smooth. Its roughness creates friction that helps to hold it in place. By cutting new, smoother channels, these floods can reduce that friction. This is incredibly important because the Ross ice shelf acts like a natural barrier or a stopper, holding back the colossal glaciers flowing from the Antarctic interior. The decadal pulses also change the chemistry of the water. The flood brings warmer, saltier seawater further inland, allowing it to come into contact with the base of the ice in areas that are usually exposed only to fresh, cold meltwater. Saltwater has a lower freezing point than freshwater, which means it can accelerate melting at the base of the ice shelf. Over time, these repeated surges of warmer, saltier water can contribute to the gradual thinning of the ice from beneath. This hidden melting process is a critical factor that was previously missing from our models of how ice shelves behave. Understanding this dynamic system is essential for predicting the future of Antarctica. The stability of the ice shelf is directly linked to these hidden processes. If the rate of melting from below increases, the ice shelf could weaken, thin, and become more prone to breaking apart. Since the ice shelf holds back land-based ice, any weakening could allow those glaciers to flow faster into the ocean. This discovery of a pulsating ice-carving river reveals that the continent is far more active than we ever imagined. The fate of the ice is not just determined by the air temperature above, but also by the hidden plumbing system working away in the darkness below. The processes happening deep beneath Antarctica, hundreds of kilometers from the coast, might seem remote and disconnected from our daily lives. However, they have profound implications for coastal communities all around the globe. The great ice sheets of Antarctica and Greenland act as the planet's frozen reservoirs, holding enough water to raise global sea levels dramatically. The stability of the Ross ice shelf, which is being shaped by this hidden river, is a key variable in the equation of sea level rise. If this massive ice shelf were to weaken and break apart, the inland glaciers it currently holds back would accelerate their slide into the ocean, contributing significantly to rising seas. What scientists are learning from this subglacial river helps them build more accurate climate models. By understanding that powerful floods and warm salt water are thinning the ice from below, they can better predict how quickly the ice might be lost in a warming world. These discoveries are a stark reminder that our planet's systems are all interconnected. The burning of fossil fuels in our cities and towns releases greenhouse gases that warm the atmosphere and the oceans. This warmer ocean water can then circulate all the way to Antarctica, seeping beneath the ice shelves and accelerating melting in these hidden, vulnerable places. The heartbeat of this frozen continent is, in a way, connected to our own actions. This connection between our actions and the stability of distant ice sheets is a call for all of us to consider our impact. While the challenge of climate change is global, the solutions can begin at home with simple, conscious choices. One of the most effective things we can do is reduce our energy consumption. This means turning off lights when we leave a room, unplugging electronics that are not in use, and choosing energy-efficient appliances. When we use less energy, we reduce the demand on power plants, many of which burn fossil fuels. These small individual actions, when multiplied by millions of people, can make a significant difference. We can also make thoughtful choices about how we travel. Opting to walk, cycle, or use public transport instead of driving a car reduces carbon emissions. Conserving water at home is another simple yet powerful action, as cleaning and transporting water requires a great deal of energy. Finally, we can support policies and leaders who are committed to transitioning to renewable energy sources like solar and wind power. The astonishing discovery of life in a dynamic river beneath Antarctica's ice is not just a scientific curiosity. It is a message from a fragile world, urging us to become better stewards of the only planet we have.